Hello and welcome to the best and most comprehensive courses on discrete mathematics, the backbone of mathematics and computer science. Discrete mathematics studies mathematical structures that can be considered discrete rather than continuous. Objects studied in discrete mathematics include integers, graphs, and statements in logic. By contrast, discrete mathematics exclude topics in continuous mathematics such as real numbers, calculus, or Euclidean geometry. The set of objects studied in discrete mathematics can be finite or infinite. The term finite mathematics is sometimes applied to parts of discrete mathematics dealing with finite sets, particularly those relevant to the business. Research in discrete mathematics increased in the later half of the 20th century, partially due to the development of digital computers, which operates in discrete steps and stores data in discrete bits. Concepts from discrete mathematics are practical in studying problems in branches of computer science, such as computer algorithms, programming languages, cryptography, automated theorem proving. Conversely, computer implementations are significant in applying ideas from discrete mathematics to real-world problems. In simple words, discrete mathematics is of mathematical structures that are fundamentally discrete rather than continuous. So, together with calculus and abstract algebra, discrete mathematics is one of the core components of mathematics at the undergraduate level. Students who learn an excellent quantity of discrete mathematics before entering to the college will be at significant advantages when taking undergraduate level math courses. This course will help the students to understand the basic of discrete mathematics for their mathematical and computer science journey. So, at the end of this course, you will learn the language of mathematics and mathematical simple, helping you through your mathematical journey. In particular, this class is meant to introduce logic, proof, sets, relations and functions, counting, basics of graph theory with an emphasis on applications in computer science. Discrete mathematics course will help everyone to understand the basics of sets and prove the mathematical problems, statement using mathematical induction and various other counting techniques. Help to understand relations and various functions. Also, we can understand the concept of predictors and prepositions. Proving mathematical problems using different methods of proof also discussed in discrete mathematics. We will learn the basics of graph theory also. You will learn all these and much more throughout the 5 sections of this course. The first section will be set theory and counting principles. We know that many critical discrete structures are built using sets. So, do you know what you mean by sets? Sets are the collection of distinct objects. Among the discrete structures built from the sets are combinations, unordered collections of objects used extensively in counting. The second section will be relations and functions. The concept of function is essential in discrete mathematics. As we know, a function assigned to each element of a first set precisely to one element of the second set, where the two sets are not necessarily distinct. Functions play an important role throughout the discrete mathematics. They are used to represent the computational complexity of algorithms, to study the size of sets, to count objects, and in numerous other ways. The third section will be propositional and predicate logic. Logic is a basics of mathematical reasoning and all automated reasoning. It has practical application in the design of computer machines, the specification of system, artificial intelligence, computer programming, and other areas of computer science, as well as many different fields of study. The fourth section will be method of proof. To understand mathematics, we must understand what makes us correct mathematical argument, which is nothing but proof. When we prove a mathematical statement is true, we call it a theorem. A collection of theorems on a topic organize what we know about this topic. To learn a mathematical subject, a person needs to construct mathematical argument on this topic actively and not just reading explanations. Moreover, knowing the proof of a theorem often makes it possible to modify the result to fit new situations. Everyone knows that proofs are essential throughout mathematics, but many people find it surprising how important proofs are in computer science. The proof is significant in computer science also. Proofs are used to verify that computer programs produce the correct output for all possible input values, to show that algorithms always make the right result, to establish the security of a system, and to create artificial intelligence. Furthermore, automated reasoning systems have been designed to allow computers to construct their own proof. In this section, we will explain that makes a correct mathematical argument and introduce tools to construct these arguments. The fifth section will be graphs. As we know, graphs are discrete structures consisting of vertices and edges. There are different kinds of graphs depending on whether edges have direction, whether multiple edges can connect the same pair of vertices, and whether loops are allowed. Problems in almost every possible discipline can be solved using graph models. We will look at some of the examples. Using graph models, we can determine whether it is possible to walk down all the streets in the city without going down a street twice. And we can find the number of colors needed to color the region of a map. Graphs can be used to determine whether a circuit can be implemented on a planar circuit board. Using graphs, we can distinguish between two chemical components with the same molecular formula but different structures. Also, we can determine whether two computers are connected by communications link using graph models of computer networks. We can also use graphs to assign channels to television stations. We will introduce many different graph algorithms to solve various real-life problems. So, the ideal students for this course are students currently studying discrete mathematics or computer science, or homeschool parents wanting to support their kids in their discrete mathematics skills, or anyone interested in learning the backbone of mathematics. So, I hope you are excited as I am to start this journey. I am looking forward to see you soon in subsequent sessions. Thank you.